guys, welcome back. Now let's talk a little bit about the back. Hopefully you did this. You're gonna have to do this yourself, but depending on how much time you got in class. So you're gonna type in the teacher data to Statlet. And then you're gonna type in the student data. So depending on which class you have, and it doesn't matter which one, if you missed class today, you can pick this data. And if you were here in period 7, you could choose this data here. And so make sure you enter both, and you should get, you should be able to use the program to do a dot plot, a side-by-side, and a histogram. Okay, so, but it says, it's nice. It says copy one of these graphs. So that's nice. I guess that's less work than I thought I was giving you. And so in one class, the Statlet was being a little wonky. So I actually took the teacher data and the student data and made a stem and leaf plot by hand. So this is what's called a side-by-side. You could pick any other one you want, but this one's called a side-by-side stem plot. And you notice sometimes I say the word stem plot and sometimes I call it a stem and leaf, and those terms are used interchangeably. Okay, now I have to compare. So I can compare, but I have to use each of these things, and this is a rubric, guys. If I don't talk about each one, I'm gonna risk missing out on points. So I usually ask students to just write it out. So if I have to compare the teachers and the students, I could use a couple different measures of spread. And now that you're thinking about these as like bar graphs, you can see that this looks right skewed, right? It's dropping off to the right again. So the students are right skewed. And if I look at the teachers, same thing. It's dropping it off, dropping down at the higher numbers. So I can say both. Now I have to put context too, right? So both students and teachers shape is right skewed. Okay, outliers. I still don't see any numbers really out of whack. I could maybe say this number 39, but both groups have no outliers. And if you wanted to try to say, I think maybe 35 is an outlier, I'd take that too. That's totally okay. Center. Well, when I look at a measure of center, I could do a lot of ways. There's probably 3 or 4 ways to do this, but I can just look at the number in the center. So if this was your student data, I could see 1, 2, 3, 4, 5, 6, 7, 8, 11 is in the middle. So for my student, the center is about 11 for one group, or I think we said more like it's 7, between 7 and 10, so I'll say 8. My teacher center, my number in the center of my teacher would be, working my way in, 1, 2, 3, 4, 5, 6, 7. So it'd be somewhere between 13 and 14. Now it feels like I've answered the question, right? But I really haven't, because just reporting out the numbers isn't answering the question. It said compare them. And this is as much an English class as it is a math class. So we have to say, using comparative language, the center of the students is lower than the teachers. So in fact, this is a complete answer in purple, and this is just kind of showing my work, but the purple is what I need. In fact, I could have left off these numbers. They're looking for me to compare, and I really want to know which one's higher or which one's lower. Now let's talk about the variability. That's going to be the spread outedness. So there's going to be a lot of ways we can measure variability, but one way we said is just the range. So again, I can list out the numbers, or I can just go straight to the answer. Which one is more variable than the other? So if I compare the student range, the student's numbers range from 20 to 2, so that's 18, and the teacher's range from 35 to 6. So I'm hoping that you would write a sentence that said, the students have a smaller range or a narrower range, less variability. Okay. So the way this thing is graded is I literally swoop in and I read, did the student talk about shape? Yep, there's the shape. Did they talk about outlier? Yep. Did they talk about center? Yep. And did they do it comparatively? Yep. Did they talk about variability? Yeah. They said one is less than the other. And last but not least, there's always like a little caveat. The last point to get full credits is you have to have context. So you only have to talk about context once in the whole problem. So you just can't forget that before you, and I talked about it almost each time. I think I didn't really talk about it with outliers, but notice I mentioned students and teachers. So if you're comparing dogs and cats, you need to make sure you mention context at least once in the whole question or you won't get full credit. Okay, we'll continue to practice that all year long actually, but just as your first look at this. Now, let's talk about this, and then this should give you a chance to try these out. So talking about our notes here, I really just described it in words. So I'm just going to kind of codify how one goes about describing a distribution. All right, so as I mentioned a minute ago, we are not going to forget to use context. And we must do so comparatively. So we need to make sure to use words, usually words that higher, lower, longer, ly words. Similarly, so ly and er words. Now, we have 4 components of this: shape, outlier, or outliers, could be more than one, center, and variability. We'll be learning a few ways to find these things, but again, I'm just going to give you a few words to pick from. Usually we say something is skewed left, skewed right, or symmetrical. That's kind of nice, right? That's kind of our data with this bell shape. And symmetrical just means fold on top of itself. It looks the same on the left and the right. So outliers is data that's out to the left or the right. So a data point or points that's too high or too low. And usually the measures of center, we use the mean or the median. And then actually, depending on which measure of center we use, we might use a couple of different ways to calculate variability, but in general, it's the idea how spread out is the data. So just kind of tapping into your prior knowledge, students usually think about this idea of range. Remember, each time I have to use comparative words. Okay, so with that in mind, let's take a look. Maybe pause the video, give question 1 and 2 a try if you haven't already, and then replay the video to kind of check your work. Okay, welcome back. It says, what % of students scored higher than 16 points? So I'm going to sit here and go, oh, and I'm going to count the dots. 2, 4, 6, 8, 10, 12, 14, 16, 17. So 17 out of 21. So I would take that as a final answer. I'd also take this. I'd also take this. All right, any of those would be fine. Describe the shape of this distribution. So it looks like it's tapering down to the left. So we're going to call that skewed left. Now, it says, are there any potential outliers? So they're kind of being loose here. I don't have to commit. But so since they were kind of loose, I might highlight this one here, right? So I would say the score of 11 is much lower than the rest of the data. So it could be an outlier. Why did I write all that? Well, it said why. It's a math class and an English class. I have to say why. I can't just stop there. Okay, next one. Here we got a back-to-back stem plot, and I kind of reviewed that a minute ago, so hopefully you feel a little bit more comfortable with that. And we've got to go through each of these. I got to talk about the shape, the outliers, the center, and the variability. And I have to do it with context, and I have to do it comparatively with LY and ER words. That's a lot of work on my hands here. So let me think about my context. It says 19 middle schoolers were asked to take their pulse rate after exercise and they're resting. So this should make sense that in general, if this was what it was before, and then it increased, right? It went up. So the center is higher after they exercised, right? Than before. Okay, so I've compared it, and I've also talked about exercise. So I did all the above. I used my context, I used my ER words, and I compared the two. And the center is about here 70 something for resting, and it's about here 90 something. So I don't have to actually write numbers. I just have to kind of be specific about I'm comparing. Now it looks like maybe these are potential outliers. So we would say that. For resting, 120 is a potential outlier. And 146 is a potential for after exercise. Right? Shape. It looks as though they're both similarly skewed, right? So it's the same people. Both distributions are similarly skewed right. And last but not least, variability. So looking our max and our min, it looks like after our resting, after our exercise, has a bit higher range of 60 compared with 52 for resting. So if you went ahead and calculated those, that's what you'd get. Thanks for joining us, guys.